Hey, this is Math 8, Unit 8, Lesson 10, Applications of the Pythagorean Theorem. Okay, so we're going to explore some applications. Here we go. First off, we're going to look at some closest estimates of some square roots. So we're going to look at a square root like square root of 24 and decide, okay, what is that closest to? 4, 4.5, or 5? And you want to figure out what it actually is going to be closest to and explain your reasoning here. And we have several of these to take a look at today. So we can first of all take a look at square root of 24. I think about kind of what's near it. So I know, like, for example, the square root of 16 is equal to 4, and the square root of 25 is equal to 5. So when I think about 24 being in between here, square root of 24, it's definitely much closer to 5 than it is to 4, and it's probably even closer to 5 than it is to 4.5. So it'd make the most sense to say it's closest to about 5. Okay, just kind of estimating there. When I think about square root of 7, I know that the square root of 4 is 2, and the square root of 9 is 3. So I think in between here I have 5, 6, 7, and 8, and we're talking right now about this point right there. I know that the halfway point is between 6 and 7. That's about where 2.5 is going to be, right? So 7 is somewhere between, square root of 7 is going to be, in this case here, it's going to be probably closer to 2.5, right, than it is to the actual 3 value. So, because it's only about, what's a half step from there, and it's 2 whole steps from there. So I'd probably go with that. It's closer to about 2.5. Okay, just an estimate. When we look at square root of 42, what's nearby is square root of 36 and the square root of 49, right? So 42 is in between there. So we think about our numbers. We have 37, 38, 39, 40, 41, 42, right? And we're going, wow, got a lot of space there. So that's 42. So 42, if I add 6, I get to 42. If I subtract 6 going this way, I get to 43. Okay? So 42 is somewhere pretty close to about the middle of both of 36 and 49. Square root of 36 is 6, square root of 49 is 7. So it makes sense for here to say, let's go with about 6.5. Is about a good estimation for the square root of 42. On this last one here, okay, there's also another number on the back side, 3.50. We're looking at 13, 13.25, 13.5. So let's take a look at each one. First, we have the square root of 10. Well, the square root of 9 is equal to 3. So if we're doing 10, we're doing a little bit more. Let's just go with like maybe 3.1. Okay? So we'll do square root of 10 is equal to about 3.1, just as an estimate there. Okay? Now, if we think about square root of 97, that's pretty close to what? The square root of 100. Square root of 100 is about 10. Well, this is going to be a little less than that since it's down there, so maybe about 9 point, I don't know, let's go 9.8. Let's just throw a number out there. So now if I add those up, 3.1 and 9.8, we're sitting at about 12.9. And so as a result of having to kind of go up on this value but down on this value, I end up with something less than 13. So 13 is probably a safe estimate for that one right there. Again, these are just approximations for which estimate is closest to the actual value, and if you use a calculator later on, you could probably check and see exactly how far off you really were in your approximations. Now in our activity today, first one's called cutting corners, and it says that May and Tyler were standing at the corner of a large rectangular field and decided to race to the opposite corner. So let's just say they're standing over here, and they're going to get over here. Since May had a bike and Tyler did not, they thought it would be a fair race if May rode along the sidewalk that surrounds the field while Tyler ran the shorter distance directly across the field. The field is 100 meters long and 80 meters wide. So let's say it's about 100 this way and 80 this direction. Okay? And Tyler can run at 5 meters per second. So Tyler's going to go this way. He's going to go 5 meters per second. And then May is going to go this way, and she's going to go 7.5 meters per second. So before you make any calculations, who do you think is going to win? Well, we know that there's a difference here between going on this route compared to the diagonal. question is how much of a difference is that going to be? Okay, so can we make a calculation about who's going to win or not? That's up to you. I'm going to let you decide, May or Tyler, who do you think is going to win the race there? Make your own guess there. Now, once you figure out who's going to win, by how much do you think they're going to win by? By a lot? By a little? Think that through a little bit for what do you think is going to happen. Okay, May is going to have to go a total of 180 meters. We know that much, but we don't know Tyler. We also know May is going to go faster, 7.5, than Tyler, so maybe that extra speed will help her cover the little extra ground. Not sure quite yet, but let's take a look. So in terms of who wins, if we take a look at May, May's going to be traveling, we know for her, 180 meters. Now she's going to do that in a time and a rate of 7.5 meters per second. Okay? So 180 divided by 7.5 tells us that it's going to take her 24 seconds to go from there to there. For Tyler, though, we're not quite sure. We don't know how far he has to go. So for Tyler, we need to figure out how far he has to go first of all. So that's going to be, this is our right angle, so that's our hypotenuse. So do 80 squared plus 100 squared equals Tyler's distance squared. So 80 squared is 6,400. 100th squared is 10,000. That equals Tyler squared. So when you put that together, we have 16,400 equals Tyler squared. So we take the square root of that, and square root of that. And the square root of 16,400 is about 128. It's about that for Tyler. It's about 128 meters. So now we're going to take the 128 and we want to divide that by his rate. Again, just estimate about 128. His rate's 5 meters per second. And that gets Tyler at about 25.6 seconds is how long it will take him. So overall, May's going to get there in 24 seconds and Tyler's going to get there in 25, which means May is going to be the winner, but she's only going to beat him out by about 1.6 seconds faster than what Tyler can do. It's not a huge difference there overall. 1.6 seconds, not too bad for that race there, but definitely a little bit faster. Okay, pretty cool. But then we're just using the Pythagorean theorem to figure that out. Now let's see how we can use the Pythagorean theorem for this next one. Internal dimensions. All right, and I'm going to keep it on this page. The back question wants us to actually solve this, but I'm going to keep it right here for you, okay? It says, here are two rectangular prisms. Which figure do you think has a longer diagonal? Note that the figures are not drawn to scale. So the diagonal here is going from one corner all the way across the center of that cube or prism to the opposite corner. Okay, so you're not just talking about a diagonal on a flat 2D surface, you're going from one side across the other side, okay, all across the middle there. So, which one do you think has a larger diagonal? Again, that's up to you to kind of think it through. If you thought about volume, for example, the volume of this prism is 5 times 5 times 5, or in this case here, that's going to be about 125 cubic whatever it's going to be. Over here, the volume is going to be 6 times 4 times 5, so that's going to be about 120. So you might say because this has a greater volume, you might think that L might be a little bit longer, maybe L, okay, and because maybe it has a greater volume. Now we're not measuring volume, we're measuring distance, but maybe because it has a greater volume, you might think that it might go further. I'm not sure. But let's take a look here. The next question does say, well, go ahead and figure that out. Calculate the lengths of both diagonals. Now to do that, we have to make sure we're calculating the right measurements here. There is actually a diagonal line that we can use to draw ourselves a triangle. We can use this diagonal here, plus we can use the height of this one right there, and then if we go across the base like so, we can create another the other leg of that triangle. Okay, so to do this, and we can do the same thing here, we're going the diagonal, we have the height, and then we're going to go across the base corner to corner to make that triangle. So in doing so, what happens is I know that the height of this one is 6, for example. Height of this leg is 5. What I don't know is this length, or these lengths here. That's what we're trying to find. We're trying to find these lengths here. That's our goal, is to find whatever that length is going to be and whatever that length is going to be. But I have two missing sides. How can I find this length here? Well, notice, what do we have right there? We have a 4 by 5, and that's a right angle here. It's hard to tell, I know. We have a triangle right there. Just like over here, we have a 5 by 5 right angle, and we have the hypotenuse right there. So we can find out what this hypotenuse is going to be by figuring out this length there. So let's look at k. K, if we take 4 squared plus 5 squared, that's going to give us our hypotenuse squared right there. So this is 16 plus 25 equals our hypotenuse squared. And 16 plus 25 is 41 equals our hypotenuse squared, which means we take the square root of both. The square root of 41 equals this length here. So we can make this length right here the square root of 41. Right there. Got it? Now over here, we have 5 squared plus 5 squared equals our hypotenuse squared. This is 25 plus 25 equals hypotenuse squared. So 50 equals hypotenuse squared. Square root of both sides, so square root of 50 equals the h here. So this length is the square root of 50. Okay, so now on this triangle, I have a triangle that looks like this. Height of 6, square root of 41, and I want to find that side. Over here, I have a triangle that looks like this. We have square root of 50 on the bottom, height of 5, and we want to find that length. So we're comparing those two there. Again, these are both 90-degree angles, so now we're going to do our same kind of equation we did before. So we'll do the square root of 41 squared plus 6 squared is going to equal our question mark squared. Okay, so this becomes 41 plus 36, which is equal to, in this case here, 77 equals, and we'll call this x squared, which means the square root of 77 equals x. Over here, we'll do the square root of 50 squared plus 5 squared equals x squared, or call it c squared, whatever you want to do. This becomes 50 plus 25 equals x squared, so 75 equals x squared, or the square root of 75 equals x over here. So between these two triangles, the one that's larger is the square root of 77. So this is actually going to be the longer length, or diagonal, than the L one's going to be. But it did take us several steps, but we just used the Pythagorean theorem a couple times to get this hypotenuse, and then that hypotenuse became the leg of the next triangle there. So kind of fun and kind of cool to play with those things there. And that's the way it works with the hypotenuse or the Pythagorean theorem. Once you know a leg or two into a right angle, you can find the missing measurements. And that's your summary really for the day, is that the Pythagorean theorem can be used to solve any problem that can be modeled with a right triangle where the lengths of two sides are known and the length of the other side needs to be found. So we can use the Pythagorean theorem to solve problems modeled with a right triangle. Okay, and so an example here is if I know how tall a tower is and I know how long a cable is going to be, I can see how far apart to pull that in order to make it secure. Okay, and we can figure that out, use the right things and methods. All right, I'm going to pause there, let you work on your homework, and we'll come back and check it together in just a few seconds. All right, here we go. Homework for Math 8, Unit 8, Lesson 10. Applications. A man is trying to zombie-proof his house. And this was pretty funny. I read this today and went like, oh my goodness. We've made it through 3 whole curriculums, and I'm on almost last problem, and we finally found a zombie. Just trying to make it fun for you guys, I guess. So he wants to cut a length of wood here that'll brace a door against a wall. The wall is 4 feet away, so there's this length right here, 4 feet away. Okay. And he wants the brace to rest 2 feet on the door, up on the door. So there's our 2 feet there. How long should the brace be? So we have a 2 and a 4. That's our right angle. So that's our hypotenuse. So we know that 2 squared plus 4 squared is going to equal our c squared. We can call the brace the c squared. So in this case here, 2 squared is 4, 4 squared is 16 equals c squared. So 20 equals c squared. We'll take the square root of both sides. So the square root of 20 equals c. Now can we estimate that to get a little bit closer? Sure. We know the square root of 16 is 4. The square root of 25 is about 5. So the square root of 20 is pretty evenly set between these two, isn't it? Right? It's about 4 away from that and 5 away from that. So we could make an estimate of being approximately 4.5 feet away. Would be a good approximation of what that's going to be. It's definitely square root of 20, but we could say square root of 20 is somewhere about 4.5. All right. On our next one, at a restaurant, a trash can's opening is regular and measures 7 by 9 inches. So let's just draw this real quick for you. We have a 7 by 9 inch opening. The restaurant serves food on trays that measure 12 by 16. So 12 by 16. Jada says it's impossible for the tray to accidentally fall through the trash cans because the shortest side of the tray is longer than either edge. Okay, do you agree or disagree? So what she's saying is that because we have a 12 is not going to fit this way, and a 12 is not going to fit this way. The question, though, is we could agree or disagree based upon her statement. We would agree with what she's saying, but could it fit in? The question needs to be answered, well, what if about the diagonal? Could it fit the diagonal way? So we have to find out if she's right or wrong. She's right in saying it can't go this way, true, but she's not accounting for the diagonal. So the diagonal is we found by 7 squared plus 9 squared equals the diagonal squared. So we have 49 plus 81 equals c squared. This totals up to about 130 equals c squared. So the square root of 130 equals c. So this length right here is the square root of 130. Well, what is the square root of 130? Well, the square root of 121 is 11, and the square root of 144 is 12. So this is going to be less than 12, right? 130 is right here. This is less than 12. So I can't get something that's 12 inches in there because this is less than 12. So she's right, it can't fit in there, but it also can't fit in because even the diagonal is not large enough to fit there. So she's partly right, but also partly wrong in her explanation. The explanation should say that the tray is too long both in its length, its width, and its diagonal compared to the trash can's opening. All right, number 3. Number 3, there are 4 things for you to take a look at, and it wants you to select all the sets that are 3 sides. To do that, you're going to take one value and square it, add it to another value, and square that, and see if it's equal to the final one squared. If it works, then you're going to say that it's going to be true, and you're going to select it. I'll tell you right now that on my notes, there were 2 out of the 4 that actually worked. And I'm going to let you figure those out because otherwise it's just me squaring stuff up and making it work for you. Alright, and that's part of the practice for you to do today. Number 4. For each pair of numbers, which the 2 is bigger or larger and how much more? Alright, so sometimes if I have 10 to the 9th, 10 to the 9th, that's the same, so I'm comparing the 12 to the 4. So the larger one is definitely 12 times 10 to the 9th, but how many times larger is it? Well, to do that, you can think about 4 times what number equals 12, or divide both sides by 4. We would say that 12 divided by 4 is 3, so x equals 3, so it's 3 times larger. Okay? Because 12 is 3 times larger. That's our bigger one there. Here, same base, 10 to the 12th, 10 to the 12th, so we're comparing the 1.5 compared to the 3. The 3 is our bigger one compared to 3. So 1.5 times what number gets you to 3? Well, again, you could divide 3 divided by 1.5, which is going to tell you 2. So it's about 2 times larger. In this case, we don't have the same base. So if I want to make the same base, then I can make this one go down to 10 to the 4th, which means moving the decimal 1 to the right. This becomes 60 times 10 to the 4th. So 60 is larger than 20, So this is larger. And how many times larger is 60 than 20? Well, 20 times what number can get you up to 60? Well, that's going to be x is equal to 3. So it's 3 times larger there as well. And number 5, we have a point, 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. So here's a point right there. It says the line is a negative slope, meaning it's going to go down this way, which could also be in the line. Well, 2, 0 is here. Could that be in the line? Nope. 4, 7. 4, 7's up here for B. Nope. 5, 4. Well, 5 would be here and 4 would be over here somewhere. So it could be, right? That's kind of going down from there. As long as it's negative from that point, that's a possibility. And then 6, 5 is on the same line straight across. That'd be a nope. So D is a nope. The only one that could possibly kind of go in a negative way from there would be C. So I like that one the best. And finally, number 6. Noah and Han are preparing to jump rope. Noah can do 40 times in half a minute. Han can do y times in x minutes for y equals 78x. They both go for 2 minutes. All right, so for Noah does, and for 2 minutes, he does 40 for every half a minute, which means he does 80 in 1 minute, and we're going to multiply that by 2 for 160. Okay, for Han does, his time is going to be 78 times the number of minutes, which is 2. And 78 times 2 is 156. So Noah's doing more. He's doing 160 compared to Han's 156. All right, that is it for the day. Have a great day, and we will see you next time.